height of robotics and is one of the pioneers in creating robots with artificial intelligence.
So far we have developed the various industrial robots, but as a research we need to develop a new area. Especially in Japan, it's very important to develop new applications for supporting our daily life. Therefore, I started the project for interactive robots.
Repli Q1 Expo was modelled after famous NHK TV newscaster Ayako Fuji. Professor Ishiguro believes that only very human-like robots can elicit natural responses in humans and thus integrate in human society. In Professor Ishiguro's language, the technology is known as android science. In order to create a machine that can mimic the human brain, it must not only be able to process information at the speed of the human brain, it must also have cognitive functions such as visual recognition, navigation, and the ability to learn. Just what is cognitive science? Cognitive science is the multidisciplinary study of mind and behavior. Artificial intelligence, or AI, involves the study of cognitive phenomena in machines. One of the practical goals of AI is to implement aspects of human intelligence in computers. To make Repli Q1 Expo as human-like as possible, Professor Ishiguro equipped it with 42 small, quiet, air servo actuators. Using compressed air, these actuators allow precise control over motion and can give between 130 and 180 degrees of mobility. Tactile sensors, also embedded under the skin, are connected to sensors in the environment. The Actroid is surrounded by floor sensors that will sense movement and transmit signals to the control system. Using these sensory inputs, the autonomous program installed in the Actroid can make smooth, natural interactions with people around it. Microphones are used to pick up speech for processing as well. The interactive Actroid can communicate on a rudimentary level with humans by speaking.
Hello, my name is Yu Ando. I'm really thrilled you can join me on One Step Beyond. Enjoy!
Before Repli Q1 Expo, Professor Ishiguro developed an Actroid modelled after his own daughter. However, the female android was jerky and unnatural.
My first Android was my daughter's copy, but I couldn't install the enough number of actuators for the small body. Therefore, it looks very human-like, but the movement was very jerky and, it looks like a zombie.
As a follow-up to Repli Q1, the professor created Repli Q1 Expo. However, he soon realized that there was a bottleneck issue. Repli Q1 Expo still couldn't carry out long-term conversations with humans. Advanced artificial intelligence had yet to be achieved. Undeterred, Professor Ishiguro set out to find a solution to this shortfall. But what would that solution be? Up next, in a surprising move, Professor Ishiguro shocked the world further when he revealed that he had successfully made a robot clone of a famous man. Who is the secret man? Now that Professor Ishiguro has successfully created the world's most human-like android, his next mission is to create a robot that can hold a long-term conversation with humans. At the ATR Intelligent Robotics and Communication Laboratories, Professor Ishiguro, the leader in humanoid science, holds weekly meetings with his students. He aims to nurture a new generation of robotic scientists to carry on his vision of creating robots that are as close as possible to human beings. To top his previous android developments, the quirky professor decided to base his next project on none other than himself. The result was Geminoid HI-1, an android modelled after the robotics expert. Wearing the same clothes and sporting the same hairstyle, Geminoid has successfully fooled many of Professor Ishiguro's colleagues and students.
The third reason is, if I make my copy, I don't need to go the foreign countries business travel anymore, if I use this robot.
This system extends the applicable field of android science and enables Geminoid to have an intelligent conversation with its human counterparts. The science of Geminoid consists of 3 elements. First, Geminoid's robotic structure has been made to resemble the minute details of its creator. Silicon skin was molded from a cast taken from Professor Ishiguro. Shape adjustments and manually painted skin textures were based on MRI scans and photographs. Next, for the teleoperation interface system, Professor Ishiguro's lip corners are measured by an infrared motion capturing system in real time, converted to motion commands and sent to the Geminoid server by the network. This enables the robot to imitate precise human movements. Professor Ishiguro uses microphones and a headphone to capture and transmit sounds. The captured sounds are encoded and transmitted to the Geminoid server via Internet IP link. This technology opens up a whole new area of scientific possibilities. Is artificial intelligence closer than we realize?
Artificial intelligence is a little bit different, and even if we build the human-like appearance and behaviors, computer is quite different from human brains, and it's a very hard problem, right? So I think we cannot develop perfect artificial intelligence.
Professor Ishiguro is not about to stop pushing forward. Since the success of Geminoid, his team at Osaka University has come up with a new humanoid, CB Square. CB Square is a child robot created to coexist with humans. To achieve this goal, the robot must be able to maintain long-term interactions and relationships with humans. The researchers at Osaka University are hoping to use CB Square as a new research platform for human-robot communication and development. The 130 centimeter tall, 33 kilogram CB Square has an appearance similar to a child-sized boy. It was designed this way to establish natural interaction with humans. Embedded in CB Square's small body are 56 flexible pneumatic actuators that generate human-like motions. These air actuators allow the robot to perform whole-body, flexible movements. Next, to make the interaction more natural and safe, the robot's body is covered entirely by soft silicon skin. Sensory organs are also needed to achieve greater interaction with its human caregiver. CB Square's sense of touch is realized by 197 tactile sensors embedded beneath the skin. These sensors allow the robot to react to humans when it's touched. CB Square's vision comes from cameras mounted in his eyeballs. The omnidirectional cameras help the robot to determine its position and orientation by analyzing the images it captures. The sense of hearing is simulated by microphones mounted externally above the head. The technology enables CB Square to spontaneously respond to the sounds generated by its human caregiver.
I believe that Japan will be the first nation that accept the robot in our society. People should accept the robot in their daily life.
And the one robotics event whose fame extends well beyond Japan's shore is the Robo Cup. Robo Cup's yearly competition event attracts teams from 32 countries. Competitors from the United States to Singapore come to pit their soccer-playing robots against each other. This is Team Osaka's soccer-playing Vision 4G robot. It's 45 centimeters tall and weighs a little bit more than 3 kilograms. Its 40 MHz CPU-controlled body has 23 degrees of freedom, allowing it to stand up from a prone position. A head camera plus object detection algorithms based on color differences allow it to locate and approach the ball before lining itself up for a kick. Its successor, Vision Vigos, is slightly bigger and heavier, but comes with 8 times the processing power and 4 times the camera resolution. Vision Vigos can walk over uneven terrain and has goalkeeping skills to match its fancy footwork. Vision Vigos can dive to the left or right to stop balls like a human player. In the one-on-one humanoid competition, Vision Vigos dominates the game like a pint-sized Cristiano Ronaldo. Robot Vision 4G's secret weapon is the omnidirectional camera installed in its eyes. The robot comes with image sensors that provide it with 360-degree field of vision and allows it to detect the soccer ball swiftly. Due to a change of rules for RoboCup 2008, Vision 4G's successor Vigos uses a fisheye lens instead of the panoramic sensor. This greatly reduces the robot's field of vision. The limitation, however, didn't limit Vigos's capability. He won the Best Humanoid Award in the 2008 competition. To the Japanese, robots are both science and fiction. They are the brave warriors that protected them during their childhood, and beloved domestic companions waiting patiently on them at home. It is this supportive culture that views robots as benevolent technology and visionary attitude that has pushed Japanese robotics